Hi, I'm Tim Spann, developer advocate for Apache Pulsar, and I work at Stream Native. My talk today is entitled Architecting Your First Event-Driven Serverless Streaming Application on Kubernetes. And that's my title because I couldn't think of a longer one, even if someone paid me. So it's really long, but I tried to get all what we're trying to talk about in there. So I work on what I call the flippin' stack, which is Apache Flink, Apache Pulsar, and Apache NiFi together. All those one really nicely on top of Kubernetes or on VMs or in Docker or in bare metal or whatever you might have, even smaller handheld systems, whatever makes sense. I've been doing streaming systems and different data architecture at a number of companies. So that's ranged from things like big data, cloud, IoT, streaming, those sort of things. Worked at Cloudera, Hortonworks, Pivotal, HP, PwC, and now Stream Native. Every week I put out a newsletter, try to cover all the things going on in data, streaming, containers, Kubernetes, anything interesting open source out there. So subscribe to my Flipstack weekly, no ads in there. What is Pulsar? Apache Pulsar is an open source cloud native messaging and event streaming platform. So it's two different things in one. I know some people think messaging, event streaming, maybe the same thing. Not exactly. There's a little bit of variation in there. Now, from the beginning, when Apache Pulsar was first developed at Yahoo, it was built to be in containers, was designed for the modern cloud, designed when it was created, the thought of this is going to be in a hybrid environment, maybe multiple clouds. It's going to run in containers. It's going to have to support microservices. And it's something we're seeing a lot of people using because it's very hard to run these days without Kubernetes, and trying to get away with just one cloud is also a difficult thing to do. So when we said messaging and streaming, yeah, they're a little different. So with messaging, we think of message queuing. And there's a lot of different message queue systems out there, tend to be used for work queues, usually don't care about order. It's a good way to distribute your code in different environments, especially something like Kubernetes, in different languages, different servers, environments, things that separate your apps from each other. This is a great way to distribute that, get code, get data from one place to another, have it executed RPC style, and all of it asynchronous and all of it durable. You're not going to lose your data unless you've designed it to be lost. That's your decision there. Now, streaming, pretty similar. This is where people get confused here. The difference is order is really important in streaming. And also we tend not to want to lose the data. I mean, in messaging, sometimes you're like, I'm firing the identical same message 1,000 times in a row. It's a status that rarely changes. Lose some data, resend it, whatever. In streaming, each event, each message, each record is really important. I don't want to lose it. Make sure the stream is stored, it's durable. I get things in order. I get things, I don't lose data. I can roll back, get the data again. These are things around Kafka, Kinesis. Common use case here is something like CDC, where I have a change happen on a production table, and I want that message, that record, that event that, hey, this record changed. Here's the old data, new data, what changed. Send that somewhere so you can update some other systems, or to trigger some bit of code to happen when that happens. Oh, someone, got a new deposit. Let's send them an email. Let's update another system. Someone left an account. Lots of things can happen when something gets changed in a relational database or a production system. So how does Pulsar work? Under the covers, as you expect in any modern, large, scalable system, we've got a cluster. Now, what's different about Pulsar is that it was designed to be cloud native. So we've got compute and storage separate. Metadata is somewhere else, and that metadata can be kept in something like Apache Zookeeper, but also now to embrace the Kubernetes world, could be an etcd, and you could use that to control metadata, names of topics, all those things that are ancillary to running the code. The Pulsar broker is handling, who do I talk to, who gets that message, pass it through, stateless, maybe a little bit of cache if need be. Underneath, Apache Bookkeeper handles storage. It's a real ledger system. This is not just a couple of flat files lining somewhere. Get 3 or more nodes, stripe your data, so we're not going to lose it if something weird happens. We make sure we keep consensus. We make sure we don't lose data. Now that's a lot that you could do with Pulsar. I don't want to do a full talk here, talk of all the hundreds of benefits there, scalability into the petabytes, thousands of nodes, support for multi-tenancy, which is awesome for Kubernetes. So we'll set up a tenant, namespace, and topics underneath there, all of them secure. So if I need to have just one big cluster and 1,000 apps on it, no problem. Support for millions of topics, great. So there's a lot of cool features. Built-in support for tiered storage. You decide you only want to keep a little bit of storage in the current cluster, maybe just last half hour, last hour of data. That's what's critical. And then I can have Pulsar automatically tier that out into S3, Google Cloud Storage, HDFS, ADLS2, whatever you might have out there. Great. But we want to build some serverless apps. It is kind of in the title. If you need to know more on Pulsar, we'll send you some links. So Pulsar Functions is how we do our serverless, open source serverless, not tied to any particular cloud or vendor. You can run this anywhere you have Pulsar, which is awesome. So a function is a pretty simple design. You specify a number of topics, and this is dynamic. If you need to change this, you could use the REST endpoint or the command line interface to just adjust how many topics go in there. So say I create a new topic, I could add it to this function to handle it. Like I've got one for sentiment. I got one that maybe looks up, addresses, all that kind of small functionality, microservices, do something on data. So we connect these topics to this function. So anytime a new event or message or record, whatever you want to call it, comes into a topic, triggers the function, we run that function's logic. And from there, if we decided to automatically map that to an output topic, when I'm done with it, I do my return, that result goes there. If there's an error or something I want to log, we'll send that to a log topic that you specify. What makes this even more powerful is inside the function, I could dynamically send that to other topics. So say I'm watching the data. If it's normal data, just send it to the output topic that you wanted. But if it has certain value, the results of sentiment or this, results of some machine learning or something else, I can create a new topic on the fly and send the data there. So say it was CDC. Oh, you sent me a new table. I better create a new topic, send that to there, so someone on the other side can move that into, say, a NoSQL database, what have you. Lots of options there. Currently, we're supporting Java, Python, and Go. Extensible API here in the open source. So if there's another language you want supported, like say Rust or Kotlin or Scala or something else, you could add that yourself and put a request out there and we'll see what happens. Java and Python are awesome ways to do this. Support for all those libraries that you might want to use. Great way to get things done and do this in a very robust, scalable way and very easy to write. If you look at a function, this is an example one in Java. I just extend the function, say what the input and output are, do some logic in there, and then just return the results. Pretty straightforward. If I want to do, say, NLP in Python, import, say, Vader, import something to process JSON. I make a class, put an init if I have anything to do in there. Process is called for each event. That is that input value there. Context gives me access to things like the log, the ability to create a new topic, all those sort of things, forwarding and routing the message somewhere. Here, pretty easy code inside of Python. I'm just setting up a little row, converting it into JSON, and returning it to the output topic. Got that full source code available if you're interested. Now, to make this even more powerful, just having those functions and have them running in Kubernetes, great. Stateless, boom, deployed, event-driven, awesome. Now, to make it even more powerful, there is an open source project called FunctionMesh. This allows me to build application pipelines that are a combination of sources which someone wrote already that can pull data from different places like MongoDB, MySQL, Kafka, Scylla, whatever you might have there. Combine your functions and maybe other ones. There's a bunch in the open source I've written and others have, and some syncs, create a pipeline together and build this whole thing out. Deploy this in your own Kubernetes environment. Pretty easy for both Pulsar and the Pulsar function mesh. We give you all those YAML configuration files you need. You use standard tools like kube control, uses the standard Kubernetes APIs. We've got the operators out there for you to handle it. And it's very easy. All the Helm charts are out there. We've got all the documentation. Push a couple buttons and everything's deployed. Scale up, scale down, add more functions. Very easy. Wrap it all up in a GitHub and deploy. Underneath the covers, we have a full set of features in here: geo-replication, load balancing, support for other protocols. So if you want to have a Kafka streaming platform and Pulsar, you don't need both. Turn on Kafka support within the Pulsar cluster, and now you've got one Kubernetes cluster that lets you do Pulsar and Kafka same time, mix and match, send them back and forth between each other, built-in tiered storage, all open source. If you want to use Stream Native, has some extra operators to do a couple other features if you need to. Grafana, Prometheus, all of that is out there for you. Pretty straightforward. If you're interested, we got some cool videos showing you how to deploy your microservices, going in depth on different things you could do with functions. Pretty easy out there. Here's the link to the charts. Here's some examples. If you don't want to have to set up your own Kubernetes, which maybe you don't, just use Stream Natives, very easy. If you want to learn more on Pulsar, we've got an academy that you can get trained at for free. All on-demand training, very easy. This has been a quick talk. Hopefully you've learned a little. Join me at the rest of KubeCon in Detroit. I'll be in the Stream Native booth. We can go through some deployments, some examples, run through some code, and we'll have some other experts there to talk to. And enjoy yourself, and hope you like the rest of the conference. Thank you. It's been awesome.